So let's discuss with the cell level information which you have. Let's go ahead and discuss about how the cells can actually make a battery module, right? So the chemical engineers working in the companies, they will be working on the different recipes and they will find out which one is a viable formula. And those cells can be as small as the coin type to very big as high kilograms as 20 kilograms, right? Maybe in weight. So one cell is not going to run the entire car or a vehicle. There will be so many different cells or modules, right? So here you will find one of the cylindrical form factor which we have discussed just now is this one, and there are so many other cells which are prismatic like this and pouch like this, right? So these are three popular battery form factors which are cylindrical like this, which are hard case or prismatic like this, and this is the pouch cell. So whatever the cell you find in your cell phone, they are of pouch type, and sometimes they get they change their shape and the size, and they get bulge outwards, right? So these are the pouch cells. So if I show you some of the battery pack electronics or arrangement, what happens in an electric vehicle battery pack. So here you will find an interesting video which I can play, and you will get the enough idea about how the battery pack is assembled. So this is from Samsung SDI, and if you take multiple number of cells and connect them in series and parallel, that is going to form your complete electric vehicle battery pack. So here this Samsung SDI manufactures lithium ion cell, and this one is being the positive side and this one negative side. If you connect these two, they are going to be connected in series, right? So series and parallel connection, once they are done with the proper holding, and if you connect properly with a battery management system as well, which is I'm sorry, let me play this video again, and I will show you what is a battery management system, what it will look like. And if you have seen any of the video which is do it yourself, you will find such arrangement. If you have this cells available, you can actually make your own battery pack for your electric cycle. So these are the cells, and a battery management system is nothing but an electronics board sitting on all these cells, and that is going to not only sense the voltage and current, but also the temperature of all the cells. And then you can actually mount it in an enclosure, and that is ready to ride your bicycle. So this is how the cells are converted into the vehicle battery pack. And in a similar way, if you have seen something about the Tesla battery pack, they are using similar 18650 cells, and they are used in thousands, right? 7 to 8,000 number of cells are grouped together, and that is going to make a larger battery pack for a car. So why lithium ion battery requires a battery management system? So as I said, it's not safe to charge and discharge lithium ion cells above and below specified limits, where these limits are not in voltage and currents, but also in temperature. So there has to be some protection provided by someone who is continuously monitoring voltage, current, and battery, right? So what happens if you further discharge your battery? If you discharge a completely discharged battery, right, what will happen? That is not going to remain safe, and your cell life cycle is not only going to affect it, but its overall performance will be also affected. So why battery management system is required, which in case lead acid battery was not requiring, right? Because there are so many other parameters, right? So for safe operation, we need a protection circuit, and all these protections are at voltage, current, and temperature level. So you must implement all this protection in the battery so that to avoid any failures, right? Or to avoid any fire hazards. So another point is, what is the level of the battery, right? You are using your cell phones and you keep on looking at what is the level of the battery and when should I connect the battery to the charger, right? So user must be aware of what is the present situation or what is the state of charge of the battery, right? So a battery management system is required to indicate what is the state of charge of the battery. Someone has to count that how much energy is put in and how much is taken out, right? So there has to be some counter inside of the battery which will continuously tell that this much percentage is now left, right? And that is the capacity, remaining capacity of the battery. Another reason why battery management system is required, even though those cells are of same manufacturer and of same batch manufactured or born at the same time, they are going to have slightly different charge and discharge behavior. So for example, in the previous case, the previous video I have shown where the many number of Samsung SDI cells were used in an electric bicycle application. If any one of the cell is going to get discharged first and hit the limit of lowest discharge cutoff voltage, then entire battery pack is now going to stop functioning, right? So even if the weakest cell, or we can say the most discharged cell, hits the limit, the entire battery pack is disconnected from the operation, right? So it is very, very important to maintain the voltage and the state of charge level at all cells within the battery pack. And how it can be done? It can be done by balancing, right? And that is why the battery management system is required. So what balancing is going to do, whatever the cells which are overcharged or whatever the cells which are having different state of charge and different voltage levels, they are going to get to the same mean level or the average level of all the cells inside a battery pack. Another purpose of using a battery management system, the battery has to communicate with other systems, right? So while charging, if your battery temperature increases, the battery should communicate that to the charger, right? While discharging, if any fault has occurred within the battery pack, it should tell the motor driver that there is something wrong within the battery pack and we need to now shut down, right? So communication system, monitoring and protection, state of charge calculation and balancing, these are the parameters which are implemented, or these are the features which are implemented in an electronic circuit board, and that is called a battery management system. So I hope you have now got enough idea regarding a battery management system. And now I think I can switch my screen to actually show you one of the simulation, which is a demo simulation in the MATLAB. So what you can see in the MATLAB simulation, do you think is it going to be a good idea to actually check about the life cycle of the batteries in reality, right? Do you think you should charge and discharge batteries to their fullest life cycle in actual experimental level? Instead of that, if you have your battery model mathematically available in a simulation environment like MATLAB, you can play with that, right? So this is going to be your first exercise with the battery, where you don't have the actual battery with you, but you can do some analysis which can be as near as the practical data. And why I have chosen this demonstration to show it to you, it is because this is going to charge and discharge the battery pack as the vehicle does, right? So here you can see this is one of the electrical circuit, right? If you as a mechanical engineer see that there is a series connection and a parallel connection, right? So here you have a high voltage battery which is 100 ampere hours, right? And there is a capacitor connected in parallel, and there is a controlled current source. So this is going to be a battery, and this is going to be the load, right? What is that load? Let's see what this load looks like. So this is nothing but a signal generator where it is going to give you the IDC in amperes, that how much ampere is going to be taken out of the battery or how much ampere is going to be fed to the battery. So what happens when the vehicle runs, that is going to not only discharge the battery, but your battery can get charged with the regenerative action happening by the motor driver. So in electric and hybrid electric vehicle, it is possible that you can charge and discharge battery while the vehicle is running, right? Not charge as like a charger, but to some extent with regenerative braking. So here you have a complete model of a high voltage battery pack, and yes, you can study about its temperature rise over the period of time, and yes, you can change the pattern of discharge also, right? And if you provide the negative values over here, you will actually discharge it, and if you provide positive values, you are going to charge the batteries. And the battery state of charge will be calculated by this block, and you can actually see how much is the battery remaining once you have any drive cycle implemented as IDC, right? Let me share some information with you regarding the drive cycle. What is a drive cycle? Drive cycle is nothing but uh, the pattern in which you are riding the vehicle, right? So if you take let's say around 3600 seconds, right, how you are going to ride your vehicle. Initially your vehicle is at zero speed, let's say this zero speed, and then you start your vehicle with some speed, and it is going to take around minus 100 amperes as a discharge current, right? And you change the speed, the value of the current is also going to change. Now, if you apply sudden braking, then regenerative braking can actually charge the battery with 100 ampere. So this is how you charge and discharge battery while you are running your vehicle, right? The pattern in which you run your vehicle is called a drive cycle, and you can actually implement the drive cycle equivalent current in this signal builder block and identify what happens to the battery. So how many number of cycles you can take out of the battery, right? So if your battery is 100 ampere hour and at some voltage, and you find out the kilowatt hours, and if you have the current signature or current usage of the battery pack from the vehicle, you can carry out a simulation where if after let's say 10 kilometers of ride with this pattern, how much is the state of charge left, right? Or how much is the reduction in the battery state of charge. So this is possible to simulate over here. So let me simulate this, and let's see what are the results. So I think I'm able to see something with the Zoom related context. I will take some time to actually open it up. Let me maximize this. Okay. So here I have pressed the run button, and I'm going to run this simulation for 3600 amount of seconds. So why 3600 seconds? Because that is the data point which we are feeding into. So for 3600 of seconds, if we charge and discharge the battery pack like the vehicle does, how much is the reduction in state of charge percentage, right? And we can actually assign how much was the previous state of charge, right? And you can actually assign what is the ambient temperature and how much is the temperature rise at the end of running this simulation. So this is very basic simulation. You can open your MATLAB and do this exercise of charge discharge of a battery. And you can feed only charge current and identify if you charge the battery for continuously at 100 ampere for 1 hour, then your battery will get charged fully in 1 hour, right? So that is the meaning of ampere hours. So, and we are going to see at the end of the simulation what is the reduction in state of charge, right? So if we have this simulation of drive cycle implemented as IDC block or signal builder block like this, how much is the state of charge reduction? And if the state of charge reduction is, let's say 20%, so how long my battery can run the vehicle? So you can do actual very basic range modeling. So you can carry out the vehicle, electric or hybrid electric vehicle range modeling with a very simple example demo like this, right? So while this is going to take some time in execution of the simulation, I'm going to go back and explain you what is state of charge, right? So what is the state of charge? Let me come back to the presentation mode. A state of charge is nothing but remaining capacity of a battery. So if you see, it can be easily compared to the glass of a water, right? So when you say that it's a glass of a water, so whatever is the level of water in the glass, that is exactly the level of the battery in case of electrical element, right? So Q is nothing but a coulomb, which is represented as unit to represent amount of charge which is inside a battery. I, current which is entering into the battery or coming out of the battery as a discharge, maybe in another direction, and that is going to change the level of the voltage of the battery, right? So we can have the analogy with the water glass. If you are actually adding some water to the battery, sorry, for example, you are adding some water to the glass, can you accurately measure how much is the level of the water while you are adding the water to the glass? No, you have to wait and allow the ripple to go away, and then allow the water to be stable, and then you can accurately say that this is the level, right? Same thing is true while your battery is actually getting charged, its voltage is increasing, and state of charge is nothing but derived from of the voltage and the ampere hour, so that it gives you the percentage level. Right. You might have observed in your own usage of a cell phone that if the cell phone battery is below 5%, it's not always accurate that you will be able to use your cell phone for this many minutes, right? So below 5%, then the state of charge is not accurately displayed by the battery, right? So there is a challenge because of the inherent characteristics of the lithium ion batteries. So if I try to show you how are the lithium ion battery characteristics in terms of voltage versus ampere hours, they are like this. So this is voltage on the y-axis and the capacity on the x-axis. These characteristics are like this. So here it is like this. The battery discharges, its voltage decreases, and suddenly it decreases to some level which is determined by the cutoff voltage. You should never discharge battery below this level, right? So this is the characteristic, and this is what happens after let's say 80% of the usage has been done, right? Now the characteristic is moving in this direction. Some of the cell may have a characteristic which is like this, some cell might have like this, and it is very unpredictable that how much is the capacity left based on the value of the voltage, right? So, and the same is true while the battery is charging, right? Or the same can be compared with the water glass analogy. You have to actually take care when the glass is going to become nearly full, right? If you keep on adding the water at the same rate, which is the previous rate, you have to be very careful that the glass doesn't get overfilled, right? Or the water doesn't come out of the glass. So the same thing is true when you're charging the battery. It is very, very important that you charge to the level where it is not over and above certain voltage. In lithium ion case, it is 4.2 volt. So you might have observed the same thing while filling up your tank. If you are filling up your tank with, let's say, 500 rupees, your 450 rupees will get filled fast. And after some time, after once the 50 rupees amount of quantity of fuel is pending, the nozzle or the flow of the fuel is going to get reduced. Why? Because it can accurately measure that 50 rupees so that your transaction is going to be very accurate, right? So you are neither going to get more fuel, not the less. So similar things, battery has to display the state of charge very accurately. And this is very important terminology, state of charge, which is the level of the battery, right? And state of charge should be measured when the settlement has been done or the voltage becomes stable and there are no ripples, and the accurate voltage reading is also very important, right? So sometimes if your voltage sensor or something is very not reading it correctly, you may end up in the state of charge value which is having some errors, right? So this is about state of charge, and I think now the simulation must have been completed. We can go back and see the results. What are how the simulation has been done, right? So okay, so now we are going to observe with a typical pattern of charge and discharge, what are the state of charge levels. So let me open up state of charge levels, and let's see what are the results of the simulation. So what are you expecting? Yes, we are discharging the battery and equally charging the battery because our signal builder is equally negative and equally positive, right? But now the net battery level might have risen or might have decreased, right? That depends on how much is the area under the curve for this negative side and how much is the area under the curve for the positive side. So let's see what happens to the state of charge of the battery. Now, uh, let me also explain you about the battery model. Here, if you see the symbol of a battery, which is like a DC source, right? So the battery and the DC source are very different. So these are not the DC source. So whenever you do the simulation, if you use simply built-in DC source, that is never going to decrease the voltage because it's an infinite source of energy, right? So what is the difference between a DC source and a battery? So battery has a limited capacity. The DC source is of infinite capacity. Okay, so now here we have the result. So initial state of charge before doing the simulation was set to 70%, or here you can see the 0.7. And over the period of time, it went on increase and decrease. And at the end, it is around 50 to 40 to 50 percentage, right? Or 50 to 55 percentage charge has been left. So this is what you can do as a simulation. If you see the MATLAB and want to try to work out some of the simulation, you have to find out what are the battery models. Here you will find 3 to 4 different battery models, and you have to implement a system parameters, and then you can run some basic simulations like this. So you can set the capacity, you can set the voltage level, you can actually have the temperature effect also, and there can be the life cycle analysis also with the MATLAB Simulink, where you keep on charging and discharging the simulation. Obviously, your simulation will run for hours, but you will get at 100 number of charge and discharge cycles how much battery capacity is left, and that is nothing but the state of health of the battery, right? So here you will find some of the high voltage battery parameters, which is the internal resistance, the ampere hour capacities, the nominal voltage, and you can actually implement the fading also. Here it is disabled, but if you keep on charging and discharging, the battery life is going to be shortened, and that can be also modeled. Here there is a thermal pot, which means that the battery has a thermal mass of 89,400 amount of joules per Kelvin, right? So battery is going to release some amount of heat energy, and this is very, very important in terms of thermal management of the battery packs.